Comment 606 tells you that you should have differentiated. Now, if you get this comment a lot, it means that you've got a bit of a blind spot for knowing that this is a technique that's available to you, and therefore it should go front and center on a summary poster or right at the top of a little cue card containing the top 10 mistakes that you make the most often. But let me just talk for now about when it is that you're supposed to differentiate. It's if you have y and you have to come up with dy dx, or you have f and you have to come up with f dash x, so you have y and you have to come up with y prime. And again, if you have one of these and you have to come up with a second derivative, that's obviously when you differentiate. You also differentiate if you want to find the gradient of the tangent to a curve. You differentiate if you want to find the speed or velocity. Or, for ADMAS students, if you have the acceleration and you want to find the velocity, then you differentiate. And finally, for Year 13 girls doing Stats 2, if you have a cumulative distribution function and you want to find the probability density function, then you differentiate. So there's a bunch of scenarios where you have to differentiate. Now, by the way, just because differentiation does the job doesn't necessarily mean it's the most efficient way of undertaking the task. If you have a very special curve, then differentiation might not be the best way to find the gradient to the curve. Also, it might be that differentiation is too hard. If the reason why you're trying to find the gradient is just to stick a tangent on, I don't recommend that you differentiate the equation of a circle. I recommend you just stick the tangent on directly and then see if you can work out the gradient some other way. So I forgot to talk about one last circumstance where you have to differentiate. It's if you want to find the maximum or the minimum. Now, it's not the only way, but it seems to me if something is at its highest, it'll be flat, and so you differentiate and find out where the derivative is 0, or if something's at its lowest, then it'll be flat. But again, these are not guarantees. That's flat, but it's not the lowest point. And there might be more direct, straightforward ways to find out when something is at its highest or lowest. But if you have complicated algebra, then differentiation is the absolute business for finding that higher and lowest point. It's not always that you'll be told to find the maximum or the minimum. If you're asked to find the vertex of a parabola, then you need to know that that means the lowest point or the highest point. In which case you can use differentiation to find that point by setting the derivative equal to 0. Okay, comment 695 reminds you that for the Poisson, there is a very special trap, which is when the units of the average figure are different from the units with which the question is asked. So if I tell you that there are 2 breakdowns per week, that's the average figure that's named lambda in a Poisson. What if I ask you what's the probability of 4 in a fortnight? It's your job to notice that when I was giving you the average figure, I talked about week. When I was asking the question, I asked about fortnight. Now, in such a situation where they don't match, there's only one way out, which is to change the average figure so that it is now expressed in the units with which the question is expressed. So if it's 2 per week, it'll be 4 per fortnight, and you are now working on a Poisson situation with an average figure of 4, in which case this question basically amounts to asking what's the probability that you get what you would expect. Anyway, that's comment 695. It says look out for these units mismatches and adjust the average figure so that it matches the units with which the question is asked.